Hello everybody and welcome to the Homework Helper for section 5.3. My cold's getting a little worse, so my throat's a little scratchy, so I apologize if my voice squeaks every now and then. Well, I'm going to go over this section, and just so you guys know, on Friday, tomorrow, will be a quiz on all of this. All quiz questions will be taken directly from the homework. So if you get your homework done, you should have already seen the problems on the quiz and be successful. So let's go ahead and begin. So the topic is the determined points that are solutions to a system of equations. 3 points are given, boop, boop, boop. Each point is a solution to at least one of the equations. Just 1 point satisfies both equations, and this is the solution to the system. So it wants us to find and justify which point is a solution to both equations, and justify which points are not solutions. So pretty much all that it's asking us to do is to take each point, plug it into both equations, see if it works. So I'm going to rewrite it here. So I have y equals 2x minus 3, and then I have y equals negative x plus 3. And I'm going to start with a. Strangely enough, I'll do negative 2 and 5. So my y is 5, so I plug that in for y, equals 2, and negative 2 is my x, so I plug that in for x, minus 3. 5 equals 2 times negative 2 is negative 4, minus 3. 5 equals negative 7. That is not true. So I know that's not going to be the equation. Boom, boom. But that means it should be the answer for this one. So I'm just going to do that. So I'm going to plug 5 in for y. I'm going to plug in negative 2 in for x. And you see what we have here? We have this negative x. So it becomes a negative 2 plus 3. So a negative 2 is going to be a positive 2 plus 3. So 5 equals 5. That does work. All right, so let's go ahead and go on to the next one. Let's see if 2-1 works. So y equals, just make a little squiggly line to show that I'm doing new work. Y equals 2x minus 3, and then y equals negative x plus 3. All right, y is 1, x is 2, 1 equals 4 minus 3, 1 equals 1, that is true. So I know at least it satisfies that one. Let's go ahead and do the next one. Y is 1 minus x, which is 2, plus 3. 1 equals, negative 2 is negative 2, plus 3. 1 equals 1. That is true. So I actually know that this is my answer, B. But remember, the instructions asked us to justify all of them. Find and justify which point is a solution. I did that. Bing. But also justify which points are not solutions. So I have to prove that C is not a solution. So I'm going to go ahead and do that. So make my little squiggly line. And then I have the point 4, 5. Y equals 2x minus 3. Y equals negative x plus 3. Okay, so now I plug it in. 5 is my y. 2 times 4 is my x. Minus 3. 5 equals 2 times 4 is 8. Minus 3, 5 equals 5. That works. So right now I don't have justification that this point doesn't work. I have to do the other equation. So y is 5, minus 4 is my x, plus 3. 5 equals, well, minus 4 is a negative 4, plus 3. 5 equals negative 4 plus 3 is negative 1. That does not work. So I've proven that it does not work. That's the expectation for these ones. Next, let's go to the set. All right, this one's kind of cool. It's graphing equations from standard form. And so, you know, we know a couple forms. We know slope-intercept, which is our y equals mx plus b form. And now we know standard form. Now standard form is, we typically call it ax plus by equals c. But a, b, and c don't actually mean anything. You know, it's not like this is a slope, this is an intercept, anything like that. That's just what it looks like. So we have x, y equals c. That's standard form. Standard form's kind of a beast to work with, but sometimes we'll get equations in standard form. And we can convert them to slope-intercept form, but sometimes that takes a while. But what I'm going to show you here, it wants us to graph from standard form. And I'm gonna show you something to kind of help us do this a little bit more quickly. So let's say we had a line, any old line. So I'm going to draw this, and then I'm going to draw a line. This is a random line. It's not related to the problem. I'm just drawing a line. So when I look at this line, there are 2 points that I can see without there even being any numbers on it. I know that this right here, this is my y-intercept because it crosses the y-axis. And I know that my y-intercept is when my x equals 0, right? Because this is my x value, and right here, x is 0. And then right here is my x-intercept. And I know that because that's where it crosses the x-axis, right? These are my axes. This is my x-axis, this is my y. And I know right here, it's where y equals 0. Y equals 0, because this is where y is 0. So given any equation, I can find my y-intercept by making x equals 0. And I can find my x-intercept by making y equals 0. So let's look at the equation it gave us, because it wants us to find our x and y-intercepts, and we can totally do this. So if I have 5x minus 2y equals 10, if I want to find my y-intercept, I do that by making x equals 0. So I'm going to recopy this, except I'm going to make x equals 0. So I'm going to have 5 times 0 minus 2y equals 10. And now I just solve. 5 times 0 is 0. Minus 2y equals 10. 0 minus 2y is negative 2y equals 10. Divide by negative 2. Oops, we're getting off the page. So we get y equals negative 5. So I know that my y-intercept is at the point 0, because x is 0, negative 5. That is my y-intercept. Put a little bow on it. Give it to you for Christmas. Okay? So I know that now. So I can look at this and I see that my y-intercept is 0, negative 5, as we just discovered. And on my graph, I can go down 1, 2, 3, 4, 5. This is my y-intercept, 0, negative 5. Now I want to find the x-intercept. And the x-intercept is very similar. Okay? So I have 5x minus 2y equals 10. I'm just copying it down. And so to find my x-intercept, I do that by making y equals 0. Okay, y equals 0. So I'm going to copy this down. 5x minus 2, y is 0, equals 10. So that's 5x, 2 times 0 is 0, so minus 0 equals 10. So I have 5x equals 10, divide by 5, x equals 2. So I know that the point 2, because that's my x, and my y is 0. 0. This is my x-intercept, 2, 0. So I can say that here, my x-intercept is 2, 0. So that's the point 1, 2, 0. I've done that. I have 2 points. 2 points make a line. So all I have to do now is connect the dots. Put arrowheads, the show goes on forever. And I've graphed that function. This is the key to it, though. To find the y-intercept, I plug x in for 0, solve for my y, gives me a point. And then likewise, to find my x-intercept, I make y equals 0, solve for x, gives me a point. Let's put a bow on this one too. Why not? Feeling generous. All right, next section is fractions, everybody's favorite. This is just a review. And I'm kind of glad that the textbook does this, because this is still something that we need a refresher on. So when I look at this, when I look at 3/4 plus 1/8, and I'm adding them together, I need to find a common denominator. And so when I do that, is there a number I can multiply 4 by to be 8? Well, yes, I can see that that's 2. So if I take 3/4, and I want this to be multiplied by 2, but I can't just multiply things by 2 willy-nilly. I have to do, if I multiply, I have to multiply by a version of 1. So 2 over 2 is the same thing as 1. So that becomes 6/8. And you see that 3/4 is the same thing as 6/8. If I were to reduce 6/8, I would get 3/4. So now that I have this, I can do 6/8 plus 1/8 to get 7/8. We just add straight across. And so that's what we're going to do here. When you look at a problem like number 11, we can't multiply 3 by something for it to be 4. So to find a common denominator, I have to multiply this by some version of 1, some number over a number. That would be equal to this multiplied by some version of 1. So here I look at my multiples. So this goes 3, 6, 9, 12, 15. And this is if I do 1, if I do 2, if I do 3, if I do 4, if I do 5. And this is the same thing. So I got 4, 8, 12, 16. And I'm just doing multiples. I'm just counting by 4s. I'm counting by 3s. And this is if I do 4 times 2. And this is if I do it by 3. And this is if I do it by 4. And you see that I have a match here, right here, 12 and 12. So that's going to be my common denominator. So that means 2/3 I have to multiply by 4/4. And 1/4 I have to multiply by 3/3. And once I do that, I'll have it with a common denominator and be able to move from there. Multiplying, even though it's a more complicated process, is kind of easier because all I have to do is multiply my numerator by my numerator and my denominator by my denominator. So I just do 3 times 2, which is 6, and 4 times 9, which is, 36? And now I can reduce that fraction. 6 divided by 36 is 1/6, and I'm done. This would be 4 times 7, 7 times 10, 5 times 2, 4 times 9. Make sure you don't confuse these. One of the things that I see people mess up on is they try to find common denominators when they're multiplying, or they just add straight across when they're adding. Don't mix up the methods. Make sure you understand each of these methods pretty well, and that's why these are here. And they will be on the quiz tomorrow. So study up, make sure you have your homework done, and we will rock that quiz.